Alright, so this is number 29 from 10.4, and it's asking to find the area of the region that's inside both the polar curves r equals 3 sine theta and r equals 3 cosine theta. So for these kind of problems, you're really just using the standard area formula for polar. The one thing you have to pay attention to is you're going to try and find a symmetry so that you only have to use one of the two functions, and then you maybe do a multiplier of it. So what I mean by that, I guess it'll be made clear in a second. So let's just start off. R equals 3 sine theta. From the last problem we did, it was r equals 4 sine theta, and we figured out that was just a petal, a rose with one petal. And when you just have one petal for the sine, it's oriented around the 90-degree axis. So, and it's of radius 3. So let's just make 1, 2, 3. Okay. So let's see. Actually, let me make this a little bit. Let's call that 1, 2, 3. Just so we get a little bit bigger of a picture. And it'd be something like that. Well, I'll take it. Alright. And then for the other one, 3 cosine theta. You could plot the points and all that, but it's also a rose, and when it's some coefficient times just cosine theta, what it amounts to is the same thing, except that it is here. Alright, not too shabby. They're both supposed to be of distance 3. So let me just make that slightly like here. Okay, so that's the idea. And the region is this thing right here. Now, we have two curves, and we can't really make one of the bounds, well, the limits of integration, well, not yet anyways, a curve. So what we're going to do is we're going to use symmetry and try to break this up in terms of only one of the curves. So we can kind of see that this region, if we were to, let's say, cut it right here at the what looks to be pi over 4 mark, and we can double check that in a second. This area and the other half are actually the same. So if we can find one and double it, there's symmetry about y equals x or pi over 4. Now, so how we could do this is by considering, well, let's see, if we were to consider just only consider the sine one, so the black curve right now. If we were to integrate from 0 to pi over 4, we'd cover this area here. And then that would be our answer if we doubled it. So that's one way of doing it. So let me just write that out. Put that black. So let's just say area is equal to 2, because we're going to double it, because it's only 1/2 of the intersection, times 1/2, and then we just use our formula. And we said it was from 0 to pi over 4. Pi over 4 is where the symmetry happened, and 0 is just to get this whole area here. Okay, 0 to pi over 4. And then it's 3 sine squared theta, 3 squared sine squared theta, d theta. Because we're considering the black curve. So it's really just this integral. So let's work this out, and then I'm going to set it up the other way and see if it's the same. So the area, well, let's see, that's going to be 9. And then sine squared, again, we have to use the half angle. So 1/2, 1 minus cosine of 2 theta, d theta. So it's 9 over 2, pi over 4, and then 1 minus cosine of 2 theta, d theta. Now integrating that, we'd get theta, and we'd get, well, let's see, negative sine 2 theta over 2, both going from 0 to pi over 4 times 9 over 4. Okay, moving forward, let's just plug our bounds in. So we'd get pi over 4 minus, so 2 times pi over 4 is just pi over 2. And then, so that, minus, and now evaluated as 0, 0 minus, and then sine of 0 is 0. So that contributed nothing. So we're left with, let's see, 9/4 times pi over 4, and then sine of pi over 2 is 1. And then cleaning it up a little bit, let's see, let's just make the common denominator on the inside 4. So pi minus 2 over 4, or 9 pi minus 18 over 4 should be the solution. And now let's set it up the other way. So we used, in this case, we use a sine function, but let's try and consider the cosine function. So to do this, we'll use this area instead. We'll use, last time we used the bottom one when we went from 0 to pi over 4, but let's go from pi over 4, oops, we'll use this. So we're going to go from pi over 4 as the lower angle of the region, all the way up to pi over 2, because that would cover this entire region, and the rest would just be empty, and that's fine. So that would work, or it should anyway. So area is equal to, again, the 1/2 and the 2 are going to cancel, but it would be pi over 4 to pi over 2, and this time it's cosine squared theta 9 d theta. And if we work this out, well, let's see. We're going to have 1/2 again from the half angle, and we're going to have 1 and then plus cosine of 2 theta, because this time we're using cosine. And this is the integral, pi over 4, pi over 2 d theta. Integrating that, we'd get pi over 2 minus pi over 4 for the 1 term, and all of this is still 9/2. And then the cosine of 2 theta, integrating that would be sine of 2 theta over 2 from pi over 4 to pi over 2. So that first term still stays. Pi over 2 minus pi over 4 is pi over 4. And then evaluating the sine, well, the sine of pi over 2 times 2 is sine of pi, which is going to be negative 1 over 2 from the 2 in the denominator. And then that's minus, and then sine of 2 times pi over 4 is sine of pi over 2, should be 0. And then you can see that this expression is actually identical to this one, so we know we did it right. And there you go, 2 different ways of setting it up, both of which are correct. So again, the idea here is to use this formula and somehow use symmetry to only use one of the functions, and limiting it between 2 values of theta.